So in this video we're going to look at converting a Newman projection to a Fischer projection. And so the first thing you're going to want to do is convert it to a sawhorse projection. Now when you do this, you're going to kind of view the bond that is there between the Newman projection. So here we're drawing a sawhorse projection, which means that we've kind of turned our head to the side and we're going to look at the bond between the carbons. And so you can see the bond there, and so if we just kind of fill in all of the pieces, you can see now that we have everything that looks exactly the same as the Newman projection, except for the fact that now we're showing the bond. So there's everything there that we filled in. It looks exactly the same as the Newman projection, except now we have the bond that's there. Now, the next thing you want to do is you're going to rotate everything so that it is eclipsed with the Newman projection. So we're going to move everything up. So here you can see we're going to make our rotation. We're going to move all of this so that we have the eclipsed version of our Newman projection, now our sawhorse projection. So you just fill in all of the atoms that we need to put in here. And now you can see that we have everything that's eclipsed. Again, remember, it's kind of like looking at your Newman projections. Instead of now you're looking at it from the side, besides looking at it dead on. Now, if you do this, you can now see that we have something for this sawhorse. If we look directly underneath the sawhorse, in other words, flip the sawhorse vertically, so if we view from underneath and we look at the sawhorse, look directly under that, then we see something that might look like this. Whereas now the CH3 that was there is going behind you, and the NH2 would also be behind you. And if you were to view this, you would see that the Br and the H, they're going to be pointed out towards you. Now if you need to see this, build a model and then flip it upside down. You can see it very clearly when you build a model. So by doing this, you can see that you can convert this now to this Fischer projection. And now you can take this and you can use this to determine the absolute configuration, or you can determine R and S. So we can go ahead and rank our carbons, or our elements around the carbons that we have here. You can see that we have bromine as number 1, we have this other group as 2 and 3. And we can see that in this case we are going clockwise. But since R, or our number 4 group, hydrogen, is pointing out, we can see that we need to flip our assignment. So this would be R, but it is now S. So you can do this and you can figure out the remaining assignments by simply viewing this. Now, once you have the assignments for both carbons, you would be set to go. So continue as normal and then simply assign all of the carbons. And that's how you do this for a Newman projection. Now, if we want to look at a Fischer projection, and we're going to convert this to a Newman projection, the number one step is to convert it to a sawhorse. And so we're going to view kind of down this bond, and if you remember the way that a sawhorse looks, you can see that we have these two carbons here. We're going to kind of orient ourselves such that we see that we have something that looks like such or so. And then we're basically just going to fill in all of our carbons and the remainder of the groups. Now, once you have this, you can then sort of view it head on, and you can see that we have something that would look like a Newman projection. So we're going to kind of put ourselves directly centered from it, and we're going to view everything as it is there. So we're going to move ourselves from looking at it from the side and look at it dead on. And once you do that, you can see that you have something that looks like this. And then we're going to basically draw it such that it is in a staggered conformation. So we're just going to rotate everything just a little bit. And once you fill everything in, that's it. That's how you convert from Newman to Fischer, and from Fischer to Newman.